All right.
I think it's next week on the web.
So, if you guys could follow along with the drawings, I would be very appreciative of that. So, where we ended yesterday was with kind of a concept that I think you guys are familiar with.
I just feel like one.
Yeah. So this was at the very end of yesterday, right?
Yeah, and this is the cube and the thing and the water was displaced.
Door open because of the hiccups can mean like you're.
All right, you guys ready? So yesterday at the end, what we were talking about was that if you take this little cube and you have this water in this graduated cylinder, if I then put this in here and let it come to the bottom, what happens to the water? Does it go up?
It goes up.
Yeah, so the water level goes up. But why does the water level even go up?
Because it takes up more space.
There's volume, added volume.
Yeah, so the amount of matter can't, like two pieces of matter can't take up the same space. So if you put this in here, the water has to go somewhere, right? So where does it go? The only place it can go, and that's up the column, right? Now, we know that the volume of a cylinder is the area of the base times the height. So if you increase the height, actually it's an increase in volume, right? So if you look at a graduated cylinder, this is measured in like milliliters, right? Does that make sense? So the question is, if I look at this again, this is the change in volume as read by the graduated cylinder, right? So how does the change in volume as read on the graduated cylinder compare to the actual volume, the length times width times height of our cube?
It's the same.
They're the same, right? So the change in volume as read by that is equal to and because the cube moves the water out of the way, okay, because the cube moves the water out of the way, we actually call this change in volume has its own name. It's called the displaced volume. Today? Yeah, eventually. Okay. It's called the displaced volume. So that's how much. So the displaced volume is the volume. Now, this is true because the whole thing is underneath the water. If the cube like floated so that half of it was in the water, then half of the volume of the cube would be the displaced volume. But it's how much it moves up. Does that make some sense to you? Like I feel like this is okay. This is okay for you guys.
Yeah.
All right. Yeah, I think that's pretty okay. So what we need to know is we need to know if we think about the fact that the water pushes upward, okay? If the water pushes upward, how do we know how much force the water exerts up on an object? Okay? That's our question. How do we know with how much force the water pushes up? We talked yesterday that if the water pushes up more than the weight of the object, it'll accelerate toward the surface and float. If the water pushes up less than the weight of the object, it'll sink to the bottom. And there's a time when the force up by the water is equal to the weight, and it would just kind of sit in the middle of the water column. It's called neutral buoyancy. So how does the water know how much to push up? Okay. So this is where we ended yesterday. We were looking up something called Archimedes' principle. Archimedes' principle. So get out your Googlers. Okay, get out your Googlers, and we're going to talk about Archimedes' principle. All right, what does Archimedes' principle say?
The upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces.
So this is really interesting. So first of all, the force from the water, let's write this down. The force from the water has a nickname. So the force from the water we call the buoyant force. This is a strange word because it's Buoyant. Like, who spells things like that?
I mean,
The English language.
English language is famous.
Um,
There's a lot of problems.
Tell me another word that has a UO.
Buoy.
It's the same word.
I don't know, there's gotta be something. Look it up.
I would be surprised if there were. Anyway, it doesn't matter.
What is it? Wait, words with U and O like right next to each other?
No, would that have U then O?
Oh.
Okay.
Challenge accepted.
Can you spell that like out loud?
There's like so
I
many.
can't read it.
There's literally
Buoy?
so many.
How do you spell buoyant?
Duomi? Duomo? Fluor?
Quote?
Fluon?
Yeah, but that's because it's a Q. That doesn't
Yeah, but
count.
it's still like.
That doesn't
so many.
count.
No, I thought we were talking about B.
15 more words.
Fluorescence.
What?
Fluorescence. That literally has UO, right?
Duo.
It's a duo. It's
There's,
two people.
look at how many there are. See all those words?
Contemptuous.
There's like hundreds. So you're just gonna have to figure that out.
I guess I'm just gonna have to. I've learned my
You're
lesson.
gonna have to deal with it.
Anyway, this is called the buoyant force. So if you hear this or see this, they were talking about it yesterday, but this means the force by the water. Actually, it means the force by any fluid, but water's good for us today. Cool? So this is the buoyant force. Now, what George, can you read it again? It says the buoyant force by the water is equal to what?
Is equal to the weight of the fluid that the body displaces.
Okay. So this is what it says, and let's kind of just try to interpret it for a minute. It says the force upward by the water is equal to the weight of the water that got displaced by the object that got put in there. So I think one of the things we have to do now is we have to try to figure out how much does water weigh?
A lot.
Does it?
Like an ocean?
How about a pint?
Like, what's the amount of the water?
What if it is like carrying buckets of water?
Yeah, carrying buckets of water is like.
How much does a pint of water weigh?
I have no idea.
How much is a pint? Why don't we start there?
It's 2 cups at 16 ounces. You ever see a pint glass?
Okay, well, we don't drink beer. That's like the only thing.
I understand that you don't drink beer, but you have seen a glass called a pint glass, no?
Yeah.
I mean,
Okay.
yeah, sure.
So this is one of my favorite rhymes.
Okay.
When we're talking about water, a pint is a pound the whole world round.
That like doesn't.
A pint of water weighs a pound. That's what it says,
I
right?
mean, I guess.
Seems like so much more.
Does it?
Yeah.
Well, of course it's going to be in a glass, so I figure, how about a gallon?
How many pints are
One.
in a
Only
gallon?
Five
like
pounds.
10 pounds.
Look it up.
A gallon compared to a pint.
So it's 9.
G-A-L-L-O-N.
8.3
Did
pounds.
you take English?
Yes, I'm an AP line. I just don't have to spell in order to do it.
I thought you were in math.
So, if you see me at the grocery store, that's where I get my workouts in. Right? I'll take a gallon, 2 gallons of milk in one hand and 2 gallons of milk in the other. I'm doing my curls, right? That's how I get it. Because a gallon of milk, or water for that matter, weighs 8 pounds.
That's pretty cool.
Okay? So that also tells you that there's 8 pints in a gallon, in case you were
Yeah, I was very confused about that.
want to do the math on that one. Now, so, but that, like, you could actually feel that, right? Grab a gallon of milk, 8 pounds.
There's no way.
Okay? literally.
It feels way heavier.
So what about this? So I'm going to take and I'm going to create a box.
Babies are 8.
Babies are 8 pounds,
I
yeah.
was like 6 pounds.
They can be
You
8
didn't have to
pounds.
do,
You didn't have to do like the life skills. Did you ever take life skills? I took health. Did SJA? You didn't go to SJA.
Oh my
No,
god,
I
I
didn't
didn't
start.
All right, you ready?
Have life skills.
So you're going to create a little box,
I had to make a flower base.
okay?
I had to make.
You're going to create a little box. This box is 1 foot tall, 1 foot wide, and 1 foot deep. So it's 1 cubic foot box. Okay? 1 cubic foot box. How much does a cubic foot of water weigh?
Good question.
How much does a cubic foot of water weigh? Check your Googler now. If you fill this thing with water, how much does it weigh? Check your Googler now.
Is it
A cubic foot.
62.43 pounds.
How much?
62.43 pounds.
Yeah, that's what I got.
So, water is shockingly heavy. Okay? Water is shockingly heavy. If you just have a 1 cubic foot, that's not that big. That's just this big, right? What if you had a what if you have one of these things? You get it from like the hardware store. It's a 5-gallon bucket.
God, so it's
If you fill a 5-gallon bucket, how much does it weigh?
Whatever, 8
40
pounds.
40 pounds. So if you fill one of those with water and you're trying to carry it, that's a 40 pounds. That's not a little bit, right? So water weighs a good amount. Now here's the nice thing about it, is that when you put something in water, however much it displaces, that's going to give you how much up force the water is. So the more volume you displace, the more force up by the water. Okay? That's how things like cruise ships and battleships can float, is because they're so big in the bottom and they sink very deep in the water, which means they're displacing a ton. Okay? So let's think about it this way. So let's say here's some water. Okay? And here's your boat. Okay, here's your boat. Isn't that nice?
what's that on the top?
Oh, that's just where the people are.
It's like the,
you know, like little.
Okay? So right now, if I let this go, it's going to fall into the water, true? And so this boat is going to sink into the water. Now, it's only a little bit in the water, so it's only displacing a little bit of water, which means there's only a little bit of up force. But the farther down you put this thing, the more water it's displacing, which means that the up force on it is more. Put it a little farther down, and it's going to, water's going to push up more. The more volume you displace, the more up force you get. And it will sink just far enough to displace the actual amount of water it needs to balance the forces. If it went too far down, then the up force would be more. Well, that would be a problem. If it went too far down, the up force would be more and it would rise up. So it sinks just enough for those forces to balance. Mars makes a good point though. She says, look man, if it doesn't displace enough, then it's going to go too far under and the water's going to fill it in and you got real problems. Right. Cool? So what's the point of my story? Okay. I mean, what's the point of any of this? The point of any of this is to say, when you're going to build your boat, right, you really don't want it to sink too far down in the water. Because then you have to move a lot of water as you're going forward, right?
Yeah.
So you want the base to be big enough so that it'll sink a little bit in the water and it's not that big of a deal. Now, if, and it needs to be wide enough so that it's not too tippy left and right, okay? the wider your base, the bigger surface area of your base, the higher in the water you'll sit. If your base is narrow, then you're going to sink deeper into the water. Okay? So I think this is one of those. Now, you don't want it too wide because then you might want to have one person way over on one side and another person way over on the other. But yeah, the bigger area at the bottom, the higher on the water it's going to ride. And usually that's probably a little bit better. Okay?
Is 3 feet okay?
I'm sure it's fine. I think 3 feet wide is how long?